exactly at a specific event what has happened. You can make the corrections, and then you increase your budget for the future of your customer. So that means the customer tomorrow wants to migrate to a higher standard, then he has enough budget. But if you don't use the OTDR trace feature with the pass-fail results, which is again unique to Fluke Networks, no other company can give you event pass-fail result, then you will not be able to rectify the problem. So that's another nice feature to the product, makes it unique. Okay. The other portion, which to my opinion is very important, the third point is how accurate is your measurement and how repeatable is your measurement. Or, well, if you have a measuring stick that goes 0 to 100 centimeters for representing 1 meter, when you put it against the table, how do you know that 1 meter is a true 1 meter? Okay, especially when you come to the data communications, the correct measurement, not a pessimistic, not an optimistic, but a realistic measurement and a repeatable measurement, that is something that an end user will look for because they want to know whether the measurement is correct or not. So our solution, this is what the standard says for a permanent link adapter tip or a probe. This is out of the standard itself, and this is what Fluke Networks has given you. They have invested more money on this little guy and this guy here than on the entire product. They have spent a lot of money on this, okay? And this will give you a repeatable measured result day in and day out on the links. In comparison to the other brands, what they have is this, okay? Which they use supposedly for permanent link or even channel, I don't know what they use. But you can see a patch cord performance, we can show you that once you couple and uncouple a patch cord, the performance will drop. So that means that your tester is not giving you a realistic result. I don't know whether it's going to be pessimistic or optimistic result, but certainly it's not a realistic result. And it's not repeatable. So if you take... Yes,
can't you do like in the fiber optic when we do the patch cords, you just minus the patch cord, and then you test the link. So in the same way, whether the patch cord is very good or not, if you know the amount of the loss in that one, your meter, with a built-in electronics, you can always minus that one. Can't you do that?
No, you
instead
cannot
of putting
do it.
so much money into it.
You cannot do it because once you take a patch cord and you untwist and twist, you will get crosstalk issues.
It's true. Say like I'm saying in the fiber.
Exactly, but the problem is that the result of this that you want to minus is not repeatable. And also your measurement probe has to give you a repeatable result. Because this is the guy who's measuring. This guy, little guy, has to make a measurement. If this guy is not making the right measurement, everything is wrong. It's very simple. You have to, I will show you, if you want, you can come to our, even after the break, I can show you some pictures of what will happen if you don't have a centered plug. Because the other thing you have to remember that here, this is a random plug. That means that the manufacturer of the cable tester has bought this, and it has it's a random plug. They buy it from, for example, let's say from, I don't know, Tyco. They don't manufacture it themselves, right? They buy it from outside. And a plug which is coming out of a regular production would have a random performance. If it has a random performance, then all your measurements will be random. There will be not a realistic measurement. You have to have a centered plug. And this is what the standards specify. You have to have a plug within a certain range of performance. Outside of that range, you cannot make a realistic measurement. Okay? So what we have done, based on this, initially actually Fluke introduced the way that we do the measurement to the standard bodies, because we have, I think if I'm not making a mistake, Werner can tell us, we have 25 engineers in the standard body that they are contributing to the way the measurements have to be made or what the standards should be and so forth. So what they have done is they have specified that this is the way a plug should be. So we designed this and they tested it with the laboratories that they have like Delta or GMHT and UL and so forth and internally, and they said that a plug for a cable tester should look like this. Okay, it should be centered. And that's what they have done. So ours gives you a centered result because it's a centered plug, okay? In addition to the other issues that you will face. There's some other technical issues. If you use this, actually you will not be measuring the performance because a link starts where? Starts at a patch cord, ends at a patch cord, correct? The measurements that you do on a channel starts from behind the patch cord, so it doesn't include the plug, and ends on the other side per standard behind the plug. And the weakest link in the whole thing is the plug. So you are not measuring the performance of the plug. There's some serious implications on this, especially when you go to higher frequencies. Just to give you an example, do you know on a link on Cat6a, the signals, they use what they call PAM16 encoding. Do you know what is the signal size when you introduce it into the link? It's 13th of a volt, okay? Do you know what is the outside the size of the signal? 6/10,000ths of a volt. 6/10,000ths of a volt. That is very small. 6 divided by 10,000 of a volt. So you can see the probe that has to make the measurement has to be extremely accurate, and certainly this guy will not be able to do it. It is difficult.
Again, coming to the other question, that if you have a link, if you certify a link 100%, that it will work up to the 100% performance, right? And then when we use the
what do you mean by
patch
100% performance?
Like anything, you know, whatever, if it is meant for 10 gig or 1 gig, whatever, it will perform that one. Now, if we use a patch cord, now your equipment is gone, we use the patch cord from that supply or from that cable manufacturer, and we use that value, that will bring down the thing down, right? Mm-hmm. So even if you are certifying it for 1 meg, if the patch cords are not good, it will go to.
We don't certify for 1 meg. We certify.
No, 1 meg or 10 meg, whatever.
No, we don't even certify for that. We don't certify that. We do not certify for the application. We certify based on the cabling standard, which are a lot more stringent than the application standard. They're 10 times more stringent. Something that passes on Cat6 or fails on Cat6 might easily pass for 1 gig. But that doesn't guarantee that things will work. It's not future-proof. There are two separate things. Application standards are separate than the cabling standards. Cabling standards are a lot more stringent. You can say I can test based on channel 1180 or 1181. You can say I can check for Cat6 or Cat6a on TIA 568. It's totally different than application. They don't compare. I can easily pass application standards with even a copper or...
I think I was not able to make myself quite clear. But I'm saying that when you test with your patch cord, with your Fluke patch cord, from one end to other end, you check the performance of the cabling, right?
Which patch cord? We don't have a patch cord.
No, like this connectors.
Adapters. Yeah.
Adapters, right? Adapters, right? So you check for the performance of the link.
Yes.
So let it XY, let it be X.
Yeah.
Now, when you take this one, and when you use the patch cord, in a realistic world, patch cord to the equipment and patch cord to the user side, then the other patch cord is being used, not yours one, which is not as good as this one. So the performance will be X minus Y, right?
Not necessarily. There is a reason. Because first of all, the test that we do is called the permanent link test. It's not a channel test. It's from the wall to the patch panel.
Yeah, but we are, you know, in the real world, we are not
so what
concerned with the permanent link. We are about the whole link.
Okay, I will explain to you. First of all, the patch cord performance, you as installers, you want to do that, be my guest, but the issue is that the patch cord performance will degrade with time. So today, if you give a pass on a channel, doesn't guarantee that tomorrow you will have a pass for the same pass for the channel, because you walk on a patch cord, performance changes. But permanent link, you can guarantee it for 25 years. Why? Because it's fixed. It's permanent part that you do not touch. But should you want to add the patch cord test results, you cannot use a channel adapter to make the measurements for the patch cord. You have to have a patch cord adapter, and there's a reason for it, because channel adapter is tuned for 25 meters and above, whereas a patch cord is between 1 meter to 5 meters. One. Number two is that you are not measuring the performance of the plug. It will measure from, you're measuring a piece of a cable with no connectors at each end. That's what the standards specify. That's specifically defined in the standards. So it becomes very difficult to do that. You have to